In this video tutorial, I am going to discuss about factors affecting enzyme activity. And here this word activity, I mean to say that velocity or speed of reaction. So there are several factors. What are these factors? So factor 1 is the concentration of enzyme. Second one is the concentration of substrate. The third one is the concentration of product. Fourth one is the temperature. Fifth one is the pH. Sixth one is the radiation. And seventh one is the activator. So these are the 7 major factors which can affect enzyme activity. Let's discuss all these factors one by one. So the first one is the concentration of enzyme. So we start with the first one, that is concentration of enzyme. One thing is obvious, that if we increase the amount or concentration of enzyme in any reaction, it is obvious that it will in a direct proportion leads to increase in the velocity of reaction. So if we draw a graph of velocity versus enzyme concentration, so on the y-axis we take a velocity v and on the x-axis we take a concentration of enzyme, then we get a straight line, because this increase in the velocity is directly proportional to the concentration of enzyme. And this fact is actually a basis of measuring enzyme in clinical laboratories. See, if we want to measure enzyme, we have two options. We can either measure its concentration, that is concentration of enzyme, or as a second option, we can measure a speed or velocity of reaction which is catalyzed by the enzyme. And for the most of the enzyme and in most of the clinical laboratories, this velocity measurement is preferred over the concentration. Concentration is rarely measured for the enzyme. Rather, velocity is mostly measured. Why? Because see, if we know the velocity, we can get an idea about the concentration of enzyme, and measurement of velocity is the easier process, right? Now let us move to the second factor. The second factor is the concentration of the substrate which can affect enzyme activity. So let's consider this one. So second one is the concentration of substrate. So just like a concentration of enzyme, here in a concentration of substrate, as we go on increasing the substrate concentration, it leads to increase in the velocity. But unlike enzyme concentration, this relationship is not a direct proportion. Not a direct proportion. See why? Why it is happening? So if we draw a graph of velocity versus substrate concentration, so on the y-axis we take a velocity and on the x-axis we take a substrate concentration. In initial part it is going to be a straight line, so it seems that it is a direct proportion. Now after some substrate concentration, what will happen? It will change its shape and it will become this curve, okay? And later on it becomes almost horizontal. Why it is happening? See, in the first part, when enzyme is unsaturated with the substrate, so as we go on increasing substrate concentration, velocity also increase in the proportionately. But after some time, enzyme will start saturated, right? So there will be a curve will be observed where substrate concentration is increased, but in velocity is not increased in that proportion. And later on, the line will become almost horizontal. And during this phase, enzyme is fully saturated with the substrate, so there is no any further increase in the velocity, right? So here in this part of graph, we can say it is a first order kinetics. Why? Because here the speed of reaction is dependent on this one factor. That's why we call it as a first order. Whereas in this part of graph, we can call it as a zero order kinetics. Why? Because here the enzyme velocity is not affected by this even one factor. Okay, so here it is a zero order kinetic, and because of this reason the shape of this graph is hyperbolic. And remember, if our enzyme is allosteric, if we have an allosteric enzyme, then the graph of the velocity versus substrate concentration is going to be a sigmoid or A-shaped curve. Right? Now the allosteric enzyme is totally different kind of enzyme, and which I will discuss in a future video. Now the third factor on which enzyme velocity depends is the concentration of product. So the third one is the concentration of products. Now concentration of product shows an inverse relationship with the velocity. See, if we increase the concentration of product, then there is a decrease in the velocity of reaction. And if we draw a graph of velocity versus product concentration, so velocity V and product concentration, then when product concentration is 0, velocity will be the maximum, and product concentration is high, velocity will be almost near to the 0. So we show such graph as per concentration of product. Why it is happening? Because when the concentration of product increases, it combines with active site of the enzyme, and so it leads to decrease in the enzyme activity. The next factor is the temperature, which affect enzyme activity. So the fourth factor is the temperature. Now the effect of temperature on the enzyme catalyzed reactions velocity is not a simple one. To understand it, let's draw a graph of velocity versus temperature. So velocity on the y-axis and temperature on the x-axis. So what happens if we go on increasing the temperature? There is initially increase in the speed of reaction. It reaches to the maximum, and if we still continue to increase the temperature, then it leads to decrease in the velocity of enzyme catalyzed reaction. So one natural question arises that why in this first part up to certain temperature there is increase in the speed? Because when the temperature rises, there is increase in the random movements of enzyme and substrate. And because of that random movement increase, this enzyme substrate collision will be increase, and because of that collision there are more chances that enzyme substrate complex will form, and it will lead to successful product formation. Then if temperature increase leads to this increased collision, then why it is continued up to at certain point only? Why after certain point of temperature the speed of reaction is decreasing? And the reason for this decrease in the speed of reaction is that after certain temperature enzyme will start denaturation. Enzyme will undergo denaturation. We know that enzymes are made up of protein. So that protein may undergo denaturation, and so there will be a loss of tertiary structure of protein, as well as loss of its active site. And so now enzyme will not able to bind with the substrate, and because of that reason there is a decrease in the speed of reaction. So at certain temperature we see a maximum velocity. So that maximum velocity, its corresponding temperature, it is known as a optimum temperature. And for most of the enzyme in our body, that optimum temperature is between 35 degrees Celsius to 40 degrees Celsius. But some enzyme, they don't have optimum temperature between this range. Rather, some plant enzyme, for example urease, their optimum temperature is around 60 degrees Celsius. Right? Now for this denaturation part, most of the enzyme they start denaturation at more than 50 degrees Celsius. But here also there are certain exceptions. For example, we have Taq DNA polymerase and muscle adenylate kinase. this both enzyme, they are active at even 100 degrees Celsius. So these are the notable exception in this denaturation. Now there is one important term for this initial part where with rise in the temperature there is a rise in the speed, and that important term is a Q10. It is also called as a temperature coefficient. So what is Q10 or temperature coefficient? It is increase in the velocity of enzyme catalyzed reaction for each 10 degree Celsius rise in temperature. See, on this side, if I increase 10 degrees Celsius temperature, then what is a corresponding increase in the speed? So initially the speed was at this level, and at 10 degree rise the speed is at this level. So this rise in the speed, it is called as a Q10 or temperature coefficient. For most of the enzyme in our body, this Q10 or temperature coefficient, its value is 2. What does it mean? It means that if I increase the temperature by 10 degrees Celsius, then the speed is getting 2 times, right? So that is the meaning of this Q10 or temperature coefficient. And this temperature coefficient, this value 2 is mostly observed between a 0 degree to 40 degree Celsius range, right? Now there are several usefulness of knowing the effect of temperature on the velocity of reaction. See, we generally observed that food can be preserved for a longer time in a refrigerator, right? Why? Because we know that in the refrigerator temperature is around 4 degree to 5 degree, and at such a low temperature enzyme activity will be very low. So if even there is a presence of bacteria in the food, that bacteria's enzyme will be at a lower activity, so our food can be preserved for a longer time. The second important aspect of this knowledge is that during certain brain surgery, doctor generally produces hypothermia in a patient. It is called as a induced hypothermia. Now why doctor does that? Because see, during a brain surgery there are chances that development of brain ischemia. Now in the brain ischemia, what happens? There is a decreased blood supply to the brain. Now how this induced hypothermia help in that? Because we know that at a hypothermia there is decrease in the enzyme activity, right? So because of decreased enzyme activity, all the metabolism will be slowed down, right? So there is a decrease in the metabolism. And as metabolism is decreased, we know that metabolism needs nutrient like glucose and oxygen, right? So as metabolism is decreased, there is a decreased requirement of glucose and oxygen. And simultaneously, there is also decreased free radical generation. And both of these aspects, they help neuron to survive this ischemia, right? Now, remember, there are not only these two factors which can help survive the neurons. There are several other factors also, but these factors are beyond the scope of today's lecture. Probably in any future video, I will talk about more detail regarding this, right? Now, let us look at the next factor which affect enzyme activity, and that is the pH. So, the next factor is the effect of pH on the enzyme activity. So to understand the effect of pH on an enzyme activity, we can draw a graph of velocity versus pH. So velocity V and pH on the x-axis. And if we draw a graph, just like temperature, this graph is also going to be a bell-shaped curve. Remember, in case of temperature and in case of pH, we observe a bell-shaped curve. So here also the meaning will remain same, that if we go on increasing the pH up to some point, there is increase in the enzyme velocity, and beyond that point in the pH, there is a decrease in the pH, decrease in the activity of enzyme. So at whatever pH, we observe this maximum velocity. So its corresponding point on this pH scale, it is called as a optimum pH. And for most of the enzyme in higher organisms, for most of the enzyme, this value of pH is between 6 to 8. So their optimum pH will be in the range of 6 to 8. Whereas in case of fungi and plant, the optimum pH is little bit on the acidic side, and that is between 4 to 6. But there are many exceptions. For example, pepsin, which is secreted in our stomach, its optimum pH is between 1 to 2. It is very acidic. Okay. Then we have enzyme called as acid phosphatase. Its pH optimum is between 4 to 5, and its counterpart, that is alkaline phosphatase, and its optimum pH is on the alkaline side, that is 10 to 11. Right. Now the question arises that if we go beyond this optimum pH, either decrease or increase, then why there is a decrease in the velocity of enzyme catalyzed reaction? The reason is that pH is the main factor which can decide ionic charge on enzyme, as well as on the substrate, and as well as on the enzyme substrate complex. Right. So if that charge changes on the enzyme substrate and enzyme substrate complex, then there is chances that the optimum condition is not met and reaction might be affected. And because of that reason, velocity is decreased. The next factor which can affect enzyme activity is the radiation. The sixth one is the radiation. See, radiation is known for its alteration of the molecular structure, and this radiation includes X-ray, then beta rays or gamma rays or ultraviolet light. All this harmful radiation, they inactivates some enzyme. So it is obvious that if there is increased radiation, it leads to decrease in the velocity of enzyme catalyzed reaction. The very good example is of salivary amylase. Salivary amylase is very sensitive to ultraviolet light. So salivary amylase, it gets deactivated in presence of ultraviolet light. The last factor which can affect enzyme activity is the effect of activator. So seventh one is the effect of activators. Remember that not all enzymes require activators. Only small subset of enzyme, or you can say some enzyme, they require these activators. And these activators are mostly inorganic metal activators. Mostly these inorganic metal activators, they are cations. For example, manganese, magnesium, molybdenum, then zinc, then copper, calcium, okay, even sodium and potassium can be there as a inorganic metal activator, and rarely they can be anions. For example, chloride ion. This chloride ion, it acts as a inorganic metal activator of enzyme amylase. Now this inorganic metal activator, they can either loosely bound with enzyme, or they can be tightly bound with enzyme. If they are loosely bound with the enzyme, they are generally referred as a metal activated enzyme. And if they are tightly bound with the enzyme, they are inseparable for the enzyme, then we can generally refer them as a metallo enzyme. Just to give you example of these metal activated enzymes are enolase, which contain magnesium ions, and ATPase. These contain magnesium as well as calcium ions. Whereas As an example of metalloenzymes, we have carbonic anhydrase, and alcohol dehydrogenase. This both enzyme require zinc as their activator. Then we have xanthine oxidase. It contains molybdenum as a tightly bound activator. And then we have a cytochrome oxidase. This cytochrome oxidase, it has iron, that is Fe+2, and copper as a Cu+2 as a tightly bound activator in the cytochrome oxidase. So this was all about the various factors which can affect enzyme activity, and we had covered all of these factors. I hope that everything is clear. If you still have any confusion or doubt, please let me know in a comment section below. Thank you.